Dear students, welcome to the problem solving session on student t-test. In the previous session, we see the basics on t-test and we learned t-test is classified into two types. One is paired t-test, the other one is unpaired t-test. In unpaired t-test, it is further simplified into single mean and difference of means. In the previous session, we solved the problem on single mean. In this session, we are going to learn how to solve the problem for difference of two means. The formula for test statistics is t is equal to x1 bar minus x2 bar divided by capital S into square root of 1 by n1 plus 1 by n2, where capital S is equal to square root of n1 small s1 square plus n2 small s2 square divided by 1 plus n2 minus 2. And the degree of freedom for this problem is v is equal to n1 plus n2 minus 2. For single mean, the degree of freedom is n minus 1. For difference of two means, we have n1 minus 1 plus n2 minus 1. Simplifying this, we get n1 plus n2 minus 2. Here, n1 and n2 are the size of the sample 1 and sample 2, and s1 and s2 are the standard deviation from sample 1 and standard deviation from sample 2 respectively. So if small s1 and s2 is given in the problem, using this along with n1 and n2, we can easily find capital S and we can find the test statistics. If small s1, that is standard deviation of sample 1 and standard deviation of sample 2 is not given, then we have to find standard deviation for both the cases and then we have to compute capital S. Let us go into the problem. The IQ of 16 students from one class with mean 107, standard deviation 10, and the IQ of 14 students in another class with mean and standard deviation given. So this is going to be difference in mean, but the sample size are 16 and 14, which are less than 30. So it is going to be difference in mean for t-test since it is small samples. So let us write the information n1, n2 and the average given to the problem 107 and average mean for the second sample is 112. Similarly, the standard deviation S1, S2. Next, check whether there is an appreciable difference between the IQs of two groups. So either we say yes or we say no. Since this group 1 and group 2 comes from different population, we have to take the population mean as mu1 and mu2 for this two group. Now let us go for the hypothesis. H not always say there is no difference between IQs of this two groups. There is no change. H1, mu1, mu2. They are asking, is there any change? Is there any difference? So you say there is no difference. There is a difference, but we don't know which is going to be bigger or which is going to be smaller. They are asking you, is there any difference? H0 says there is no difference. H1 says there is a difference. So mu1 not equal to mu2. This is my null and alternate hypothesis. So it is going to be two-tailed test. Next we have to write step 3. Here both 5% and 1% data is asked. So we can find the table value for both 5% and 1%. The degree of freedom is n1 plus n2 minus 2. So v is equal to 16 plus 14 minus 2. So 30 minus 2, 28. Now we have to go to the table. For 5%, we have to find T alpha value. Similarly, we have to find T alpha value for 1% too. Now from the T table, at degree of freedom 28, 5% level is 2.05 and 1% level is 2.76. So T alpha for 5% is 2.05 and for 1% is 2.76. So let us keep this table values we'll use at the end. Next, we have to find capital S to use in the main formula. Capital S is square root of n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. Substitute the value using your calculator. Find the answer. These many steps are not needed. So my capital S is 9.4415. Next, we use the formula for t-test static, that is x1 bar minus x2 bar in the denominator s into square root of 1 by n1 plus 1 by n2. Substitute the values. S value just now we found. Substituting all the values using your calculator, we found our t value is minus 1.447. Then modulus of t is 1.447. Next we have to do the conclusion. At 5% level, t alpha value is 2.05 and modulus of t value is 1.447. So mod t value is less than t alpha. At 5% level, H naught is accepted. Similarly, we have to check the conclusion for 1%. At 1% level, modulus of t is 1.447 and t alpha is 2.76. Again, modulus of t is less than t alpha. For 1% also, H naught accepted. In both the cases, H naught is accepted. Hope you understand, students. Sometimes they will give the problem directly like this. All informations are given to us. N1 is 9, N2 is 8, mean life, that is x1 bar is 600, x2 bar is 640. Here very important, variance is given. So standard deviation is not given. So S1 square is 121, S2 square is 144. Therefore my S1 S2 is 11 and 12 because standard deviation is the positive square root of variance. Next we have to see, is there any significant difference between these two means. So this is the sample mean. We have to assume the population mean. In H naught, we have to say mu1 equal to mu2. In H1, we say there is a difference. So mu1 not equal to mu2. Substitute the values, get the t value and take the modulus. So mod t value is 6.736. Now as usual, we have to find the t alpha value. For this we need the degree of freedom n1 plus n2 minus 2. My n1 is 9, n2 is 8. According to the question, you can see here number of samples is 9 and 8 for type A and B respectively. Therefore, V is equal to 15. Now we have to go to the table. At 5% level, T alpha value is 2.131. Now we can compare our table value with the calculated value. My calculated value is 6.736 and table value is 2.131. So modulus of T is greater than T alpha. So H naught is rejected. Understand, students? And one more problem for your reference. In this problem, size of the sample N1, N2 is given. Sample mean x1 bar and x2 bar is given. Standard deviation S1 is given directly and S2 is given indirect. Now we have to form the hypothesis. Other things we can easily write n1, n2, x1 bar, x2 bar, s1 and s2. Now we have to form h0 and h1. So let us take mu1 and mu2 are the population mean of type 1 and type 2. Now they are asking, is there any difference in the mean sufficient to warrant that type 1 is superior to type 2? So they are supporting type 1. When they support type 1, it is one sided. I said the trick. If they are supporting one group one sided, then it is going to be one tailed test. Now we have to check which group they are supporting. They are telling type 1 is superior to type 2. So my H naught null hypothesis, they will say no one is superior to other, both are equal. But H1 when you go, type 1 mu1 is greater than mu2 because type 1 is superior to type 2. So we say this is one-tail test. For one-tail test, as I said, the table given to us is two-tail test. We have to learn how to find the table value alone because the remaining thing is well known to you. You know all the data. You write the null and hypothesis. You can easily write the null hypothesis and alternate hypothesis. Alpha, if given, take the value. If nothing is given, take 5%. Now find capital S and then find t value. The t value is 9.393. Now we have to find the degree of freedom, that is n1 plus n2 minus 2. That is 8 plus 7 minus 2. It is going to be 13. But the problem is we have one tail test. Our table is given for two tail test. In this situation, how to find T alpha value? Since the given table is for two tail test, but we have one tail test at 5%, that is alpha equal to 0.05. Now the degree of freedom is 13. So instead of seeing the value at 5%, we have to see the value for 10%. This is correct in the case of one-tail test. So instead of seeing for alpha, we have to find the value for 2 alpha, that is 0.10. So T alpha value is 1.77. So we should be very careful. I am telling it again. You should be very careful. I am repeating this again. If the test is two-tailed test, I can directly take the value according to the percentage. If it is one-tailed test, for 5%, we have to write the value of 10%. Similarly, for 1%, we have to go and take the value for 2%. This will give the correct T alpha value. Therefore, my T alpha value is 1.77. But my calculated T value is greater than T table value. We can easily say H naught is rejected. Hope you understand, students. In the first problem, we learn how to solve difference of means two-tailed test. In the third problem, we learn how to find T alpha value for one-tailed test. This is the difference. If you remember this, you can easily crack the problems.